Rendering is performed during indexing. It is the process of retrieving a web page, executing the code within it, and assessing the results, both the pre-rendered version as well as post-render, to identify the structure and layout of your page and your site, as well as its content. By taking the initial HTML, cascading style sheets, JavaScript, and any other files needed, the browser, or the search engine in our case, can then build a DOM, or document object model, that contains all the data and markup that the browser needs to render the page. As the search engine creates its own DOM to use for extracting content for its index, it is effectively rendering the page in a very similar way to how the browser does. Hence we call the process rendering. That information derived from the original page and the rendered page is then used for ranking, which we'll cover in the next lesson. We'll also talk about the DOM in Module 8 Lesson 1. The reason search engines need to render is because many pages add or replace content within the page using JavaScript. This can be based on user interaction. For example, some websites consist of a single page. When a visitor clicks on a link in the static menu, some JavaScript executes and the entire contents of the page are replaced with the content, text, images, videos and so on that are relevant to the link that was selected. Of course, it could be that the page content is time dependent, and so that content is collected in real time from a database, as is the case for many news websites. If you use the Chrome browser, you can use an extension called View Rendered Source, which will show and highlight the pre and post render version of the page you are viewing. There are other extensions and plugins for both Chrome and other browsers. From an SEO perspective, it is important to test JavaScript is working correctly in browsers. If it is not, then the search engines may not index it, as they may not be able to see it. This is also a good reason for ensuring web pages degrade gracefully. In other words, by showing the relevant content if JavaScript is not enabled. Once upon a time, web pages were easy to programmatically understand. However, in order to expand the functionality of web pages, JavaScript, previously known as Mocha, LiveScript, and ECMAScript, was invented. This meant that instead of static web pages, the initial code of web pages could be changed by the code that lay within it. JavaScript could be used to change HTML elements within the page according to the interactions made by the viewer. This meant that there was a need for search engines to view the content of both the initial pre-rendered page and the versions of the page post-render. In other words, after execution of all page that's used within the page. To solve this problem, Google introduced their Ajax crawling scheme. This was in order to make Web 2.0, as it was then termed, pages accessible to Googlebot. Googlebot, you may recall, is the name of Google's crawler. This approach required web developers to add special hash fragments to the URLs to indicate that they were utilizing Ajax technology. Ajax stands for Asynchronous JavaScript and XML. It also required configuration of the server to subsequently respond to special Google queries with the same HTML code that would be delivered by the Ajax itself to a site visitor. This effectively made the site crawlable without Google having to execute JavaScript in order to render the page. Of course, a complex approach like this was prone to human error on the part of the web developers and was not supported by other search engines so much. Examples of the steps required to be undertaken by web developers can be seen here on the screen. This ultimately led to Google, aided by increases in processing power, actually rendering the JavaScript itself without relying on server configuration and hash fragments in URLs. So how does Google crawl pages with JavaScript now? Web pages have more and more JavaScript embedded within them. JavaScript has more applications and users than solely Ajax. Google has phased out its old Ajax crawling scheme in favor of executing the JavaScript itself. It does this by first taking a URL from the crawl queue. The crawler then makes a request for the URL from the web server and retrieves all relevant associated files such as CSS, JS, and so on, and forwards them for processing. It is put into the render queue for this. The renderer then uses a headless version of Chrome to render it by executing the internal JavaScript. Headless simply means that the browser runs without a window to view it. As no human is going to see or interact with it, there is no need for the overhead of having a window. Once rendering in the headless version of Chrome is complete, Google stores any links found within the page for future processing by putting them into the crawl queue where it got this original URL from, and also examines the content of the rendered page in order to add it to the index. Of course, all the above does take time and resources. As such, Google can only render so many pages, despite its large server farms. This is why we have the concept of crawl budget that we described in the last lesson. The image in the slide visualizes the process Google takes to crawl, render, and index pages. But what if something goes wrong? What if your JavaScript executes correctly in your browser, but not in Google's headless Chrome on its servers? It is incredibly important for you that Google renders the content of your web page correctly. This is because if a search engine can't render your content, then it cannot see it. If it can't see your content, it can't index it. If you have several pages that have different content, but Google's unable to render them correctly, then the pages may look exactly the same to the search engine, and so it may consider them duplicates and not list them at all. In other words, if Google, and so on, cannot render your pages, then you risk being incorrectly indexed, or worst case scenario, not being listed at all. So what can cause search engines to not render our content? If we have submitted URLs, for example via a sitemap file or in Google Search Console, but they have no index meta tags in their HTML headers, then they will not be rendered. Remember that no index pre-render equals no render at all. Some URLs may have been submitted but are accidentally blocked by rules in your robots file. If your server is overloaded and so is unable to return a requested resource, then it will return a 5xx HTTP status code and not the requested resource. If the resource has not been returned, then it cannot be rendered. Redirects can be utilized to forward to another page. Google will follow these, but if they accidentally loop, which is where a redirect points to a previous redirect in the chain, thus resulting in a never-ending redirect loop, then Google does not have the resource and cannot render it. Also, Google will typically give up if it is redirected more than about 5 times. Your content will also not be rendered if your web server returns a 404 not found server error, or if it returns a page with a 200 OK status code, but Google believes it is in fact the 404 page. It won't be rendered then, and this will be considered a soft 404. And of course, if Google believes the page is a duplicate or not a canonical version of the page, then it may not render it. Besides failing to render your content in its entirety, it may be that Google fails to render your content correctly. As with before, you can usually find these errors reported within the Google Search Console. Looking at the list, although the HTML page may be delivered, perhaps the server was unable to deliver a key support file, whether that be textual content, JavaScript, a relied upon cookie, or some style sheets. The missing file may cause the content to be rendered incorrectly, often leading to one or more of the following issues. The text being too small to be read, so is ignored. Clickable elements that are so close together they can't be seen or they overlap. Hiding one of them may end up in the content being ignored. Or content that is wider than the browser viewport, resulting in content not being visible due to being off the screen. Although Google can understand the content of images to some extent, there is no guarantee that it will be successful in doing so on this occasion. The issue can be mitigated, as we've discussed previously, by adding an alt attribute populated with appropriate descriptive text to the HTML image tag. Perhaps you have an animated GIF that conveys some context or meaning that cannot be readily understood by the renderer. Using the Google Search Console for your site, you can quickly see any issues that Google has picked up, plus there are a variety of tools out there that can be used to check rendering. For example, within Chrome, you can right-click pretty much anywhere on a web page and choose Inspect. In the sidebar that opens, click the toggle device toolbar icon towards the top right to change between desktop and mobile view to see how Chrome renders your page on different platforms. The button is circled red in the image here. Alternatively, after opening the Inspect tool, you can use keyboard shortcuts. On a Mac, press Command-Shift and M, or on Windows, Control-Shift and M. This will toggle between desktop and mobile representations of the rendered page, so you can see exactly what your page looks like within Chrome. And so we come to the end of Lesson 3 of Module 2, wherein we learned what rendering is, its history, how Google renders your web pages now, what can prevent pages being rendered, whether deliberately or accidentally, and how to look at your page on a mobile platform or a desktop, whichever platform you are on. And now that we've covered crawling, indexing, and its major component rendering, we'll move on to the last lesson in this module, ranking.